Good evening, good afternoon, or even good morning from wherever you are watching, and welcome to another episode of AI Talks Live.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exum Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Cass. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英格兰Nederland.
I'm Fakasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California.
Hi, Medine Eddie Daoud from Ghana.
Hi, I'm Ana Filana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi.
Hi. Hi.
Hi.
Hi. Hi.
Hi there, just as in the video. Hi, Paul. Thanks for joining us today.
Hi, Sami.
How are you doing?
Very well.
We saw you had already this talk, the talk you're going to share with us later on about automated machine learning also for the Azure community just now. How was it going there?
Yeah, it was real cool, but it was in French. So now let's talk in English.
Well, that's good. Being able to talk multiple languages, then you can share your session also for different communities. As the global AI community is also in different languages, where AI talks is in English, of course.
Yeah.
So, Paul, you're going to talk today about automated machine learning.
Yeah.
Very cool feature. But before we go on that, for the people who do not know you, who are you?
I'm an data. I don't know if I'm data scientist or data engineer. You will see that I can't choose between the two jobs, but I really love data since 15 years now, and I'm AI MVP and data on the data platform too now.
Okay, very cool. Where are you based, Paul?
I'm based in Nantes in France, on the west coast of France.
Okay.
And the night is coming here, but it's locked down. So
yeah, like everywhere. We're all looking forward to have going back to the new normal, or how we're gonna call it.
Yeah.
Great. So, automated machine learning. What can you tell us about it?
Yeah. I want to make it's not a joke, or it could be a joke, but I would like to show you that I can, in less than 1 hour, and without any knowledge in machine learning, I can do a real good algorithm. You can see here an accuracy near one. One is the max value, and without having a data scientist, which cost maybe for $19.90 dollars a year. So it's a joke, because this session, the real title of this session could be how to make mistakes with automated ML. So this is my real talk today. So let's go. Here is the agenda. If you are not in the, I think all the audience know what is data science, but I will go very quickly to talk about the common task of a data scientist, and I will give a quick definition of automated machine learning. And after that, let's go for a contest between not between automated ML and data scientists, but a contest between the UI, the graphic UI of Azure Machine Learning Studio, and another way to do automated ML, which is the code, which is working with Azure ML SDK, which is called automl.core, and with some Python code. And I will conclude with the result of the game. I will show you some code and some notebooks in this session. I know it's quite difficult for you to read the code on my slides, and it will go maybe quickly on these slides. So here is the link of my GitHub, and you can find all the notebooks and datasets to train you on the same datasets and with all the code I will show you today. So maybe another joke before the beginning of this session. What is the job of data scientist? It's prepare the data, maybe for 80% of the time, but we have when if you are a data scientist, I know that you prefer to modelize, you prefer working on the algorithm rather than prepare the data. The whole job of a data scientist, first of all, it's to understand the business, because if you don't know what is the purpose, the main purpose, the goal of the organization you're working for, it's a nonsense. You have to understand what is the goal. And after that, it's very, very important to explore the data. Exploring the data, I was when I began in the world of data. I was a statistician. We don't know the buzzword of data scientist, and my job was to calculate some average standard deviation, and I can find much informations maybe with these techniques, but today we have to my opinion is that we have to explore the data before going to the algorithm of machine learning. We have to prepare the data, and it's we spend many times on data prep. It's quite difficult. We have many scenarios of preparation. So it's a very important step in all the workflow. And after that, it's the training of different models. We have to choose between some approach like linear approach, non-linear, like random forest, for example. And we have to compare the models on an evaluation metric. We'll see that it's very important in the automated approach. And we have to make some fine tuning, maybe like with an approach like hyperparameters. When we have the best model, we have to interpret this, because if we build a closed box, I think it's not a good idea, because we will have data in input, we will have a result in output, but if we can't say why we have this value for the output, it's not good, because customers maybe, or the law, the what we call in Europe the GDPR, European law, can ask you to explain the result of the algorithm. So it's very, very important to interpret the results, but it's not the subject today. I will only focus on automated ML, but don't forget to look at the interpretation. There's many tools today to do that. And I won't talk today about deployment, because or what we call MLOps, because it's one subject, another subject, but you will see that I will give you some tips to be a good friend of data engineers. This schema is a Microsoft document, and here is the URL to find all these this picture. So remember here that data prep is maybe the longest step, and it's quite boring maybe, and the most uncertain task is to choose the model, because now on the state of the art we have maybe 13, 14, 30, 14 models in our toolbox, and we have to choose the good one. So what's automated machine learning? If you think about finding a password, maybe you know what it's brute force. You will try every password in 8 or 10 characters. It's quite silly, but it's not very smart. But automated ML is the same thing in the world of algorithm. It means that we will take 20, 30, 40 algorithms, and we will run all these algorithms. So it could be very long, but today we have some architecture, in particular in Azure, in the cloud, to do some parallel calculations. So it won't take a long time. We can save time, maybe not resources, but we can save time. We could do automated ML without any deep knowledge in machine learning, but I don't think it's a good idea. And I will show you where we can make many mistakes with automated machine learning. So just remember that automated machine learning, it's real brute force. We take all the algorithm and we launch them on a big, quite big architecture. In one picture, automated ML needs three parts, which are the data set. We need some data. We need to define one optimization metric. It's a metric we will measure on every algorithm, and we will keep we will select the best algorithm as with the best metric value. But don't forget that we are in the cloud, and we need to put some constraints on time and cost, because if you can't make image classification maybe with GPU during 40 hours, or because it will cost very much money. So here is the definition of the automated machine learning, and what's the goal? What's the result of automated machine learning? It's a model. It's if I have to define what's a model in machine learning in very few words, remember when you draw a line in a scatter plot, it's a linear regression, and the equation is ax plus b. A and b are the parameter of the model, and we just want to store, we just want to version and save the value of a and b in a very simple model. On this picture, you can see that we are comparing many algorithms, and we do a ranking on the score, but don't forget that we have to keep an eye on the time, on the training time, because if rank number 1 is very good, if you spend 1 week to train it, it can't be a solution. Okay, so that here is the principle of automated machine learning. Automated machine learning, it's not only on Microsoft, but you can find it on other editors. But where can you do some automated ML in the Microsoft world? You can do it, and I will do it for my demo on Azure Machine Learning, the new portal. You can use some code with .NET. You can, if you know the Power Platform and Power BI, there's a license which is premium, where you can do some automated machine learning with a UI too. And we will use the free part of the automated machine learning on Microsoft, which is a Python SDK, and that's the second part of the demonstration. So when we work in the new portal of Azure Machine Learning, we have two different approaches. First one is a no-code or low-code approach, because we have a complete UI, user interface, to make some machine learning pipelines, or to do some automated machine learning. Be careful, because it's an old screenshot. You can see here that it was an enterprise license. The license disappeared in last October, so now it's on what we call the standard license. It's cheaper than it used, so it's quite cool from Microsoft. So first approach, the UI, and the second one is the code first. And here we will use the Azure ML SDK, which is not an open source project, but you can find you can download the package with a simple pip install with Python. What can we do on Azure Machine Learning? All the steps of a complete workflow of machine learning, which are training, model registry, model versioning. We can have a code editor interaction, or work in Jupyter notebooks. We can store on Azure Docker images which support the predictive function. After the training, we have to test, but after that we want to expose to the model, to do what we call the serving, and we can deploy some Docker images which keeps the scoring function. And we have some tools to monitor the response of the model, and to monitor what we call the data drift. It means that data could change in the real life, and you have to retrain your model. So it's not only arose from left to right. It's not the real life. It's quite a cycle. And don't forget, it's very my message is very I want to point this this message about exploratory data analysis, because it's very important before beginning the automated approach. Some tips here with some packages like pandas profiling, data prep, and what can you get with these packages? It's some statistics on like a summary on your dataset, mean, some average, median, standard deviation, missing values, all this one in just a few lines of code, and some charts to observe the distribution of the features. I do not I have to precise that automated machine learning, it's only for what we call supervised machine learning. What's a supervised machine learning? We need to predict a target. In the training data set, we have one feature, which is a target, which is the goal we want to explain. Let's take a simple example here. We work for some bike rental. We can do a regression when we want to predict a numerical value, like the trip duration. If you want to predict the state of a station, it's out of order or it's okay, it's a binary, it's a Boolean feature. So that's what we call classification. And the last thing is the time series. You have one feature which is numerical, and the other one is date time, and we want to predict the evolution of the numerical value. So that's the supervised machine learning, and we will do only supervised and not unsupervised or something like reinforcement learning with the AutoML. Automated ML with the Microsoft solution is based on scikit-learn, Python scikit-learn, which is a library, Python library with a lot of algorithm. Here is the list of all the algorithm in French, sorry. But you can see that it's quite difficult for newbie maybe to choose the good one, and that's all that's here that's automated ML makes sense, because automated ML will make the best choice. And we need some data, and where should the data be stored? It's on the Azure cloud, maybe on the file system like a data lake, maybe on the database, but you could, for now, you could just use some platform as a service like SQLDB, Postgres, or MySQL, but in the managed version. And my preferred one, which is Databricks, which is a Spark cluster, where you can store the data and work with Databricks to compute all the algorithm. So let's go for the first demo. I will use only the UI, and I will show you that I can make many mistakes. And I don't want to take the same datasets, and you can see on all the conferences, which are the iris. We will talk about penguins. We change today. We talk about penguins, but it's a classification too, and we have some features like the length or the depth of the culmen of the penguin. It's a little data set, but it's maybe another data set to change about iris. And we are now playing this game, which is a game of the 7 common mistakes, which we can do with the automated ML UI. So here are some screenshots about the UI. I will show you all the steps, and I will point on the mistakes. First of all, we launch an experiment, which is a new project of automated ML, and we choose a data set. the dataset should be on Azure. So no mistake for for the moment. We just give the encoding, delimiter, and declare column headers. But maybe we are making maybe the first mistake, because if you use raw data, you can't after this in the UI you can't prepare your data. You can't clean it. You can't do nothing about cleaning. So you have to use here rich data or enriched data or refined data, and not the raw one. If you have a data lake, you have, I'm sure that you've got many layers on the data lake, the raw layer, maybe the gold layer. Here is we need the gold layer. We need some clean data. Now, second step, we can check all the columns in the data set. And second mistake, we can click on next without checking all the columns types. It's very important, because in all the algorithms, numerical value, categorical value are not treated on the same way. So keep time to check all the data types. And we have just one tool to help us to profile the data, but you have just to check here the checkbox. If you don't do that, you make the third mistake, which is for you not exploring the data set. You have to do that before machine learning, but you can do here some quick profiling. I will show you what the result of profiling. One more time, it's some charts of distributions, some indicators like missing value, min, max, and average or standard deviation. So it's very important to explore your data and to understand what you have in your data set before make some algorithm. Okay, we got a good data set, and we can now continue. And we have now to define the target. Remember, we are doing some supervised machine learning, and we have to define the target. We have to choose the right column in the data set. Okay, not so difficult, but here we can make a mistake if we have some classical data. If it's just tabular data, we don't need to check here to enable the deep learning algorithms. What is deep learning in a few words? It's neural networks specialized in the, it's not so true, but we can say that it's specialized with unstructured data like images, sound, video. It's not a good idea to use deep learning with tabular data, because you will spend many time on maybe GPUs and lost money without a better result than the classical algorithm. So for mistake, use deep learning for tabular data. Okay, we choose the target. Now we have to choose the primary metric, which is the value we will look at to choose the best model. Here you can choose only one metric in the UI. So make the good choice. If you choose the accuracy, it could be a mistake with what we call the imbalanced dataset. On frauds, maybe you have 0.1% of frauds in the dataset. It's imbalanced. You will be very, very accurate if you predict 100% of non-frauds. So we could be good on the metric, but it will be mistakes in this case. So be careful on the choice of the primary metric. On imbalanced dataset, you have to choose the weighted AUC. I don't talk for now about validation. You know that in supervised machine learning, you have to train and test or validate your model. We have different methods to do that. Here, the next mistake, you have to try to choose train validation on a too small dataset. So what's a too small dataset? On the Microsoft configuration, it's 20,000 rows in your dataset. With 20,000 rows or less, you have to prefer the k-fold cross validation, which is better than the train validation split. And now we are on the end of the UI on the different windows. We are talking about featurization. It's quite complex concept but it's maybe the most important. We have to select features. You don't have to send all your columns in the automated machine learning, because if I take the well-known dataset example of Titanic, you know the people are alive or dead. In the Titanic dataset, we have an ID for each person. We have the ticket number. We have the name of the person. All these features can't generalize in a predictive model. So we have to exclude some columns, some features. It's very, very important. If you don't do that, you will make some overfitting. I will talk about overfitting in the next slides. So select features. Select the good feature type, because you can you can choose that specific columns should be a categorical feature and not numeric, because the algorithm won't work in the same way. And you probably in the real life, you will have many missing values, and we have to treat the missing values. We can exclude the rows, but it's maybe too violent method. So we can make some imputation, which means that we replace the null with an average or a median. And here you can choose the right way to do the imputation. Remember that median and average could be really different if you have some extreme values in your data set. So be careful about the choice of imputation method. So 7 mistakes: use all the columns. If it's an ID, if it's a personal name, you have to exclude these columns. Okay, we are now at the end of the process. We have to wait some time to have the results, but here is an example of the result of a run of automated machine learning. I know that the best model is gradient boosting. Max Ab's scalar is some featurization, some data prep here. The metric, it's a regression example. It's not classification, but on this metric R squared, we got 0.997, which is very, very good because the maximum value is 1. So it's a very good good run of automated ML. But maybe it's another mistake, because if we are too good on the training, like the green line here, we are maybe too much precise with the model, and we can't generalize with new values, with new data. So maybe we have to prefer a model like this, like the B model, rather than the C model, because here you can see a real gap between the metric in the train and the metric in the test. So just have a look on the test values, and be careful about the what we called overfitting. It's maybe the most frequent risk when we use automated ML. I used to talk about cross-validation. So here is the step on the 20,000 rows. Featurization, we have many options in featurization, but we don't have these options in the UI. And now we need to go to the code to make some scripts to use all the options of featurization. So let's begin the second demo, and here we are in the code first approach, and we work with the Python SDK. And we work on a virtual machine. On this specific virtual machine in Azure Machine Learning Service, we have Jupyter Lab server pre-configured. We have a kernel on this server, which includes the Python SDK, Azure ML.core, so we can start very quickly. And here's the example of code. Remember that all this code is on my GitHub. It's the same steps that in the UI. First, we declare an experiment. After that, we get a data set. And we define all the parameters of the automated machine learning. For example, I say that I will I will compare 40 algorithms, but I will exclude 2 of them, because I know that they are not really adapted to my classification task. I give the primary metric I want to use, and I can configure more precisely the featurization, maybe with all this line of code. So all the steps in the graphic UI can be done with the Python SDK. But our local machine or just a little VM we are using with Jupyter is maybe too small to train 40 algorithm. So you can choose between local compute and remote compute. Remote compute, it's the way to use other maybe a cluster of VM, or maybe a Databricks cluster to train all the algorithm. In the notebooks, we can have the results, but it's not very clear on this on the notebook. So maybe we have to go back to the UI, or we can use some widgets in the notebook which are more graphical. Another example of widget with one blue point is one algorithm, and we are looking the best one near the nearest target of 1 for the primary metric. So to conclude about this contest between UI and SDK, with the UI, I think that we can make some common mistakes if we go to if we don't spend some time to think about all the steps. We can make many mistakes. We have to know what means featurization, for example. We have to think about the features to exclude. It means that we have done some exploratory analysis before. So be careful with the UI. And with the UI, you can't go back. If you launch a run, you can't do the same run with just one change. You have to do all the steps another time. So it's quite boring, and it's not a good way to compare different runs. With the SDK, you can do some data prep because you can do what you want with some Python libraries like pandas. Featurization is you have much more parameters for the featurization. You can compute on the remote target like Databricks, and you can choose the model on many metrics and not only on the primary metrics. And after that, maybe one of the best advantages of the SDK is that you are at the beginning of a more complex pipeline, and you are working in maybe an MLOps way. You are helping the data engineers because they can take the code, simply take the code and just add some lines of codes to deploy the model. So it's maybe some times that you spend for a bigger project. So the result of the contest, SDK is the winner in my opinion. If we have to compare the price, don't compare with the data scientist salary, but what will you pay on Azure resources? You will pay for the VM time of computation, but you will pay for container registry, because when you store the model, you can create the Docker image to expose the model, but be careful because it's quite could be an additional cost. You have to pay for a little blob storage because when you store dataset on Azure Machine Learning, they are duplicated on a blob storage, and there's a key vault for passwords. So opposing automated machine learning and data scientists, it's not the good question. Automated ML, it's a tool, and data scientists needs a new tool. They need to waste time comparing models, but it's always essential to understand the business, the goals, the issues, and to understand why we are working with this data. Keep the best data for your model, evaluate the quality. I've talked about missing values, but I don't talk about some anomaly in your data. You have to correct anomalies. You have to remove some information which is not helpful for the model. We have to transform to prepare the data, and it's the job of the data scientist. I can choose all the 40 algorithm, but I will spend some money if I'm a little bit smart and I know that it's not linear model, for example, are not good, so I can exclude at the beginning and can exclude all the linear model. It's not necessary to test all the models. I can choose to between more or less complex models, because don't forget that we have to explain at the end the results. We can work with ensemble model, and we have to have a complete view on the evaluation metrics. Don't focus only on one evaluation metric, and be careful on time and cost of the training compute. Interpretation, you have some tools included in the portal, the Azure ML portal. So I think we need to keep the data scientist, and because all the data science don't is not supervised machine learning is not all the data science. We talk. We have to think about unsupervised machine learning, about reinforcement learning, but some advanced analytics too. Data scientists are here to prepare the data. I know it could be quite boring, but it's very important that it's not included in the automated ML. Selection, good feature selection, it's maybe the best way to optimize your model. In conclusion, if you want to use the Azure ML portal, you can use Designer and the UI. It's very, very cool if you are what we can call the citizen data scientist. You don't like code, you just want to try to have a sandbox on your data with a UI. It's very good for that. Or if you want to anticipate the MLOps workflows in the serving of the model, it's better to work with the Python SDK, and data engineers would thank you to work with this SDK. Just to at the end of the slides, one or two URLs, some links to find all the documentation, and the last one, all the notebooks I show you very, very quickly are on my GitHub. Thank you very much for your attention. Sami, I don't know if you have some questions.
I'm here.
Some links
we don't have
documentation, and the last one, all the notebooks I show you very, very quickly are on my GitHub.
Okay. I just need to close. Okay. You hear me, yeah?
Yeah. It's good.
Oh, okay, great. Let me hide your screen for a moment. Great. We don't have any questions at the moment, so we still give people some time to ask some questions live. You can use any chat functionality from where you are watching. Is it on the globalai.live website, or are you watching on Twitch or YouTube? Don't hesitate to shoot a question or a thank you for Paul. It's always nice. So Paul, is there any projects you've been using, like for real customers, the AutoML?
I've got some customers who want that I use automated ML, but I'm still saying that it's too it's not the good time to do that. We have in this specific project. I mean, I have to spend more time to explore the data, but my customers are very interested in the automated ML, but I think that they understand this product like in English we say the silver bullet. I think quite well, a unicorn maybe, but I used to say that we have to be careful about all the mistakes I present here.
Yeah, for sure. Cool. Yeah, actually I did a test also on it with some sales data, a lot of sales data, and compared it with the results that was done manually by a data scientist. And well, I guess my data scientist did a good job because it was exactly the same model. So it's
not maybe in the same time, but
yeah, it's not done at the same time. Well, actually, I was also talking to a customer today concerning AutoML, and the business was saying, "Oh, so then we can fire our data scientist." Like, no, don't do that.
Keep your data scientist.
Yeah, it's a really nice feature that Microsoft added, but see it as a helpful data scientist to quicker get to a good model, and then you can still fine tune it to the needs of the question that you want to answer with your model. All right. No questions are coming in. Paul, thank you very much for your time. I'm sure your voice needs some rest now after 2 hours of presenting.
Yeah.
Thank you very much. Thank you for your time, and we hope we can see you another time. For all the ones who are still watching, we'll have a little break with AI Talks. We will be back in January. We're figuring out if we will do some changes in the concept of AI Talks, but more info of that will be followed soon. Join us on our Global AI Community Twitter. Follow us on our website. And of course, if you have any messages or you have ideas, well, don't hesitate to share with me or just on the Global AI Community Twitter. So thank you all for joining, and we hope to see you all back soon.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exit Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, beneficits. I come from
I'm
Spain.
Prasant from California.
大家好，我是卢建辉，英文版Nederlands。
I'm Paul Peton from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Metin Ali Daoud, Africana.
Hi, I'm Ana Falana.
Merhaba, ben Türkiye'den Daronya'dan.
Hi.
Hi.